we're really focused on our developer community platform, Mosaic platform. It's a data-first mentality, and we operate a lot of our platform with infrastructure as code and enable the automation through our CI/CD pipeline so we can quickly deploy multimodal types of infrastructure for the different use cases. And we enable our developer communities so they can have their AI optimizations, access their Jupyter Hub, do their data science, be able to train LLM models, and support different types of hackathons and rapid prototyping and R&D operations. So bringing a whole bunch of developers into a hackathon, deploy it onto a system modality, and then see what kind of solutions we can come up with in a week. So a lot of the distributed cloud and the adoption of hyperscale hybrid cloud, those they have high cost, security vulnerabilities, there's performance issues, lack of resilience, and all these shifts from into the distributed cloud edge. So we really focus on that multimodal side of it so that we can support each levels of the data process hierarchy. So you got your DevSecOps at the bottom, enabling the next team up, getting into the data ops and the data SecOps, securing our data, bringing it, collecting it, moving on to the platform, then processing it, building our machine learning models, being able to understand what that data system, that response looks like, and then apply that with AI for your feedback loop and get into CyberOps so that we can take action on that data. So a number of the solutions, providing a ton of application tools and services at Nalej, being able to provide different types of open source software. We focus primarily on enabling the open source software, enterprise open source, onto our platform deployments, avoiding all of the license stuff and keeping it within the community so we can move between different modalities and support our developer community clients. And then making sure we have the hybrid point-to-point access so we can communicate between those multi-modes as well. And so getting into these modalities, Nalej Mosaic platform, it supports our SaaS, PaaS, IaaS, and then systems. So going from, for example, EKS in our SaaS, hosting the specific services. So every day the developer community can access that in their daily jobs. And then going, for example, all the way down to a system modality where let's go throw up one of our servers for the hackathon. And now we bring our development community out and then have that migration where they can bring data from that SaaS modality offering into that system modality. So I'm going to get kind of more into the weeds as a developer using the Nalej Mosaic platform. So this really comes into what I want to focus on is a modern schema management, and that's enabling data-centric solutions through modern data schemas. So a lot of the data sets we receive from our development community are in a lot of traditional formats, CSV, TSV, JSON. So we want to make sure that we can enable that data and operationalize this. So that really brings us into our hierarchical data solutions needs. And down at the bottom, you can see, I look at traditional software engineering, and even below that, you have your DevSecOps, throwing up the infrastructure, and then enabling the immediate services on the platform. And then we start getting into the data collection. So this is really showing the flow of how we collect data, process the data, working together, and trade off between, as you go up to the hierarchy. So down at the bottom, you have the most amount of work with the least amount of value. And then you get to the top where we're doing our LLMs and our AI and machine learning. That's the highest value. But you have to be able to apply that into a system and feed it back. And so you can put it into the context of actual solutioning and problem solving. So my flavor of choice for modern schema is Avro. And so this is a lot of learnings I took from a number of Udemy courses back in like around 2018 and 2019, and I've kind of stuck with Avro because it gives me that schema evolution capability. It gives me an ability to have my data fully typed. It presents it in a JSON format. It makes sure that I can go between different development languages, and it's a nice thing. I can evolve it over time. So being able to change my data, if an API at one service changes, well, great, schema evolution enables me to support that and not break my whole flow of data downstream, so it stays operationalized and can serve it to the right machine learning models. And then you see the other kind of going from CSV, which we also want to support because that's a traditional choice of where the machine learning and data scientists learned in a lot of EDU in CSV format and JSON format. So being able to normalize that data into a modern schema such as Avro is part of what I work to support as a developer in the side of the Mosaic platform. So schema evolution, that's really making sure that you change your API at one end and you can evolve the schema of it. It won't break the data flow. I'm going to kind of move through these. Whenever I write a service, I focus on writing, I get my requirements first, so following the standard software development life cycle, get my requirements, and the first thing I do is write an Avro schema. So whatever your flavor of choice is, and then that guides the rest of how I develop the models and classes in my application, and allows me to normalize, okay, am I receiving data in a CSV and JSON that's of this type? Now I can normalize it and make sure that I can manage it then on the platform. And so here's some further content that I apply. When we get into the cloud, we get into our schema registry. That's how we maintain and can recall as our schema versions change. So I have a nice, not only a catalog of schemas, but I have the versions of schemas so that those dependent upstream, downstream applications can continue to support the flow of data based on the context. We get into how you have your REST APIs and your REST proxies with our data plane services on Apache Kafka. And this really gets down into making a context controller for how I manage data down here at these data producer applications. And now I can use that Avro schema in my registry to manage and do the operations as data is placed and collected onto the message bus. And now I'm going to move. Okay, so my roots are in electrical engineering. I'm a electromagnetic engineer before I moved into the data realm. And so a lot of where I think of data movement itself, I like to think of it as similar to wave propagation, except I look at it as like data propagation. And a lot of the same concepts, machine learning models, understanding signals and systems. There's where you get in, if we're creating a system and you know its response, and from like training the LLM, you see data in, you see data out, I can estimate that response to the system. Similar concept to electrical engineering where you have like linear time invariant systems where you can calculate the response, know your input, and then estimate your output. So kind of a reverse way of doing that. So now I want to get into the demo. And so what this is a rotary telephone, a vintage rotary telephone. It's a performance piece that I worked with one of the members of my music community back in Portland. And what we did is we took the pulse dial here and we hooked it up to a Raspberry Pi so it'll count the number of pulses so we can send a signal. And then we converted the handle into a microphone. So on stage, my friend, he goes by the name Views, V-E-W-S, and Views and the Vibes. He'll be able to walk around, perform on stage, dial some numbers on it, and it'll send the pulse sequence enabled by the schema that I have on my Raspberry Pi. It'll enable it to trigger an effect on my local edge gateway device at the digital audio workstation. So let me pull out of this. Let's bring up the live demo. Okay, so this is known as Max for Live. And so on the Raspberry Pi, we're communicating over the protocol MQTT, and it brings in this JSON format the way that Avro serves the data. And I'm allowed to, it enables me to see the value as it comes in based on when I dial. So let's go ahead. I'm going to make sure I'm firing up my Raspberry Pi here. Let me bring that over to, okay. Make sure I didn't lose my connection. And I have a video that we can go and I can show during the question session if we run out and if it doesn't want to connect to it. Make sure I... Okay, let's watch the video. And we'll go back to the slide. We'll go back into presenter mode. Okay, so you can see that when I dial on it, this green LED, it shows that it's connected and on, and then the red LED will light up saying that the pulse dial has been activated, and then the blue one will blink the amount of pulses. So it says 3383 right now, and I'm dialing the number for data on the phone. So I think it's, what was it? We got, 3282. So you'll see in real time, it transmits that data. Boom, 32832. That's received at my local edge. So now I want to take this from a performance piece standpoint. I don't want just one device. I want to be able to scale this. So I want to be able to capture this device as well as multiple devices on stage in real time. And I want to be able to send this into the cloud so we can optimize for future performances and be able to collect that sensor data at another level. Let's go to this next video. So we're taking this data now, and I'm going to turn on my context controller at my edge gateway. And when I flip that on, so that normalizes my CSV, JSON, and different data sets into a more modern data schema type. So Avro, my flavor of choice. And it's going to take this and send it into a centralized data stream where I can do additional action on the data. So I can thanks to the modern data scheme, let me go ahead and I'll kind of move it here. So you can see 3282, and we have on this side, so this is just showing the count instantaneous value. Let me go ahead and pause this. And then on the right side, I'm showing the time series. So I can collect that data over time, and that's like this little green bar. And we have the yellow and blue ones. Those are dynamic boundary conditions, thanks to my modern schema enablement. So I can target a specific feature, apply boundary conditions to that metadata, and now I can take action. I can direct the flow of it to the right channels. And it also, as we get into questions like data governance and the data provenance, if I say that right, it all comes down to modern schema enablement. I can augment the data in real time. I can extend it and be able to take action and send it to the right users of the system. And to wrap up, I'm going to go bring up kind of just an end show. Since we did it through the video, you can see on the Mosaic, on our Mosaic SaaS deployment here, I can go in and access my Jupyter Hub instance and connect and access that data on that data topic configured by the schema. I can go here and add in and version our applications for the development team, so we can go and do our hackathons and make sure that we can keep our Jupyter solutions properly versioned, be able to migrate them between each modality, have help desk tickets as part of that deployment, forums, and multiple other types of services. So adopting open services, bringing them and enabling that collaborative community in a way that we can really make a difference in the world, in our communities, and in the corporate world, and then globally. So, and that's Nalej Technologies.